Since the graph that the LabQuest created doesn't really show many values on the X and Y axes, it's best for us to take our data and put it into an Excel spreadsheet to create a more detailed graph. So I'm going to take a moment and enter in the molarity and the absorbance of my standard solutions. Now that I have my data, I'm going to copy that data. And I'm going to go up to where it says insert, and I want to insert a chart for the graph. And I'm going to pick this first scatter plot right here, and it's going to take that data and it will create the graph for me. I want to add titles for the axes. And then I'm just going to go in and adjust these. We want to have absorbance on the y-axis. And we're going to put molarity or the concentration on the x-axis. I should also add a title. So I'm going to click on add, go to chart title, and we can call it absorbance standard curve. If I also click on the graph again, I can add the trend line, which I'm going to want to do. And I want it to be linear. And I also want to include more options where if I come over here to the side, I want to add the display the equation on the chart. And now I'm just going to drag that graph up a little bit closer to my data table. And I want to take a screenshot of that whole thing. I'm going to type in snip in order to get the Snip and Sketch app. I'm going to hit new, and I'm just going to take a snapshot of that whole piece. And now I'm going to be able to take that picture and put it into a Word document so that I can add it to my lab report. And I'm going to have a much more useful graph than the graph that the LabQuest created for us. So after you found the absorbance standard curve of the FD&C blue number 1 dye, you were to find the absorbance of the blue Powerade containing that dye. And I found it to be 0.348. Now, if I only use my data table, I can see that that absorbance falls between these two, but I really can't determine an accurate molarity based on that. I could use the graph to interpolate where I think the molarity would be by estimating where 0.348 would be on the y-axis, going over to the line and figuring out where it matches up with the x-axis. But again, the way the x-axis is labeled, I'm not going to be able to get a very accurate number. So the best way and the most accurate way to determine the molarity of the blue dye in the Gatorade is to use the linear regression equation that was given to us in our Excel spreadsheet. When I look at that equation, y is the absorbance because that's on the y-axis. 147,015 is the slope of the line. If you were to look at m, or the slope on the LabQuest data, it probably is written differently. It probably looked something like this, where m equals 1.47015 e plus 0.5. And of course, your value for m might be different on your graph, but it probably is in this format where it has e to the plus 0.5. You need to remember that e is the shorthand that the LabQuest is using to mean times 10, same way that a calculator sometimes uses that symbol to indicate to the times 10. The plus 0.5 means that it is to the 5th power. So that's the same thing as saying 1.47015 times 10 to the 5th power. And if you take it out of scientific notation, that's the same value that is written here for m using the value from the Excel spreadsheet. X is going to equal the molarity because that's or the concentration, which is what's on our x-axis. And then the last number there is the y-intercept. So since we know the absorbance of the Powerade, we can substitute that into the formula and solve for X to figure out the molarity of the blue dye in the Powerade. So if I substitute 0.348 for y, I'm going to need to subtract 0.0261 from both sides. Now, if your y-intercept was negative, you would need to add it to both sides instead. So now we're going to divide by the slope, and my answer is 2.19 times 10 to the negative 6, which equals x, or the experimental value for the molarity of the powerade. Well, now I'm going to need to determine my percent error. Remember, percent error is experimental minus the accepted value divided by the accepted value times 100. So my experimental value was 2.19 times 10 to the negative 6. The accepted value is 2.86 times 10 to the negative 6. And so my percent error comes out to be a negative 23.4. So now you're going to take your data, create a graph in the Excel spreadsheet, use your linear regression equation and your measured absorbance for the powerade solution to determine the concentration of the blue dye in the powerade. And then you're going to include all that in your lab report.